Now I want you to pay attention. Everybody has read the question? Yes? So we'll see how to solve this. The first step, you must have noted down that it's asking for distance. What minimum distance should the at what minimum distance should the brakes be applied to avoid a collision with the other vehicle? So you want to find out D. So the formula which we have where we saw D is W equal to FD. That's the only formula where you saw D, correct? Okay. Now if you see, if you want to, sorry?
No, you're asking for the D and delta X.
Same. D and delta X, same. Okay. Now if you look at the formula W equal to FD and you want to calculate D, if you have read the question, it's giving you the force is 8,000 Newton. Correct? So force is known to you, but there is no value for work done in the question. Correct? There is no value for work done in the question. So we cannot use this formula for calculating D. We cannot use only this formula. That means you cannot use this as a single formula to calculate D. Okay? Mohammed Obaid, please do not sleep. Sit straight. Okay. So now we have to think of something else which can get you work done. Yes, Abdul Rahman.
This is the formula y equal delta x. This one?
Y equal?
No, the W.
W equal F delta x. Same. This delta, this D is same as delta x. Okay? Now, I want you to be quiet and you'll now raise your hand and tell me, we don't have work done, we want to calculate work done. How do we calculate? Yes, Khalifa. We use W equal to delta KE. That means you can use the formula W equal to delta KE to get the value for work done. Mg is force of gravity. You cannot use mg because it's force of gravity. This is work done and energy. Okay. Now, so the next step, I'm going to combine the formulas and I'm going to write it as W net equal to KEF minus KEI. What is KEF? Final kinetic energy. KEI, initial kinetic energy. Okay? So I hope you can understand this step. Delta KE is KEF minus KEI. So W equal to KEF minus KEI. Now in place of W net, I'm going to write F delta X. Do you see that? Because that's the formula for work done. I'm going very slow. You can raise your hand if you want to ask something. The first step, I wrote work energy theorem. I applied work energy theorem. W net equal to KEF minus KEI. Clear? Also, focus on this word. What's this? Net. That means total work done. Okay? Now, total work done can also be written as F delta X equal to. Now, KEF, the formula for KE, kinetic energy, is half mv squared. So, half m vf squared minus half m vi squared. That step is clear? Now, we go to the next step and we check for the values. The value for work done is 8,000. Delta X is the distance which you want to calculate. Then half, now VF. There is no VF in the question. There is?
Yes. It stops.
It stops.
Yeah.
Excellent. So stops means
Zero.
VF is equal to 0. So you can eliminate this whole thing. Are you clear with this? So half mv square will become 0. So you can actually show that step. You can write here 0. 0 minus half, the mass is 1000. The initial velocity, if you read the question, you should know that initial velocity is 35 square. Now there is one thing which I did not explain. And I want you to tell me, there is one thing which I did not talk about. You must have identified what is that. Yes, Salim?
UK.
Not UK in this part. There is minus here. Do you see this? There is a minus here. What's this minus for?
For friction.
For friction. What kind of force you are using? What kind of force is given? Friction. It is coming to stop. That means friction. Okay? That's why you have a negative sign. The next step is you rearrange the equation, get the value for delta x, which is 76.6 meter.
Miss, but f delta x equals half. Miss, is this a formula or what? We combine two formulas.
We combine